This is the Chapter 5, Unit 1A test review. Problem number 1 asks you to describe the end behavior of the function p of x is equal to 3x to the fourth plus 4x squared minus 5x plus 1. Well, I graphed it to show you the graph here, but even without a graphing calculator, you could have known that the biggest exponent of x is 4, which means that the graph opens up and it either looks like a W or it looks like a parabola. In this case, this fourth degree polynomial looked like a parabola. Since it opens up, that means both ends of the graph are going up. When we write end behavior, we always call the right-hand side of the graph the side where x goes to infinity. That means it's going in the positive x direction forever. Well, since the graph is going up, and that's the positive y direction, we say that y approaches positive infinity. On the left-hand side of the graph, this is the side of the graph where x is getting more and more negative. But the graph is still going up, so we say the y value is approaching positive infinity. And this is how we write end behavior. On the multiple choice on the test, it'll probably look something like this. So please be cautious of the positives and negatives. Problem number 2 says, when dividing x to the fourth plus 2x cubed plus 16 by x plus 4 using synthetic division, which number would you use as the divisor? When we determine the divisor, which is the number that goes in your box, we take what you're dividing by, set it equal to 0, and solve for x. So in the box would go a -5. Problem 3, for a certain polynomial function, x equals 5 is a 0 with multiplicity 4. X equals -1 is a 0 with multiplicity 10. And x equals 0 is a 0 with multiplicity 1. Write an equation in factored form for this function. Well, remember when you write it in factored form, if x equals 5 is the solution, then x minus 5 is the factor, because you're really rewriting this equation so it equals 0. And if it has multiplicity 4, that means it's got a exponent of 4. X equals -1 with a multiplicity of 10 means the factor is x plus 1 and the exponent is 10. When x equals 0, the factor is just x. And if it has a multiplicity 1, that means it's to the first power. And so we usually like to write x to the first power in the front of the factored form. If you write it at the back, it doesn't really matter. This would be the factored form with a multiplicity 1 on a factor of x, a multiplicity of 10 if the solution is x equals -1, and a multiplicity of 4 when the solution is x equals 5. Problem number 4. What is the degree of the polynomial function that generates the data shown in the table? We have this way of doing subtraction in order to determine if a polynomial is linear, quadratic, cubic, quartic, quintic, or anything larger than that. We're not going to give you anything larger than that. The way it works is you take the outputs, the y values, and you subtract them. And I just always subtract them in this order. So I'm going to do -9 minus -2 is -7. -2 minus -1 is -1. -1 minus 0 is -1. 0 minus 7 is -7. 7 minus 26 is -19. 26 minus 63 is -37. And 63 minus 124 is -61. When all the differences are the same, you'll be able to determine which type of polynomial it is. If all the differences were the same in our first pass, this would be linear. Well, now let's go do a second pass, and I'll do it in a different color. -7 minus -1 is -6. -1 minus -1 is 0. -1 minus -7 is +6. -7 minus -19 is 12. -19 minus -37 is 18. And -37 minus -61 is 24. So our second pass, which would be the quadratic pass, didn't pan out because they're not all the same. Okay, so let's go do this a third time. Negative 6 minus 0 is negative 6. 0 minus 6 is negative 6. 6 minus 12 is negative 6. 12 minus 18 is negative 6. And 18 minus 24 is negative 6. Since this was the third difference, this means it's a third degree polynomial, which we tend to call cubic. Number 5, if the side of a square is 6x plus 5 kilometers, write an expression for the area of the square. Well, squares are like rectangles. The area is just length times width, or base times height. It's just that with a square, all the sides are congruent. So in order to find the area, you're just going to do 6x plus 5 times 6x plus 5, which is the same as 6x plus 5 squared. Now, I'm not sure if on the test they're going to make you multiply this out. So if they do, then just FOIL it. You would get 36x squared plus 30x plus 30x plus 25. And then the terms in the middle happen to be like terms. So it would be 36x squared plus 60x plus 25 kilometers squared. So the answer may be this, or the answer may be this. But they both say the same thing. Problem number 6 says, when asked to solve the following by factoring, 8x squared plus 3x plus 2 is equal to 6x squared plus x minus 1, what would the equation look like right before you begin to factor? Well, the same thing is true when we want to graph things in our calculator to find the zeros of a polynomial. Before we factor, we want the equation to equal 0. So I'm going to move the 6x squared. I'm going to move the x. Notice I'm doing the opposite. And then I'm going to move the minus 1. So now the right-hand side is 0, and the left-hand side becomes 2x squared plus 2x plus 3. So this is what it would look like right before factoring. Number 7, write a polynomial equation in standard form with zeros at -3, 2, and 3. So these are the zeros. If those are the zeros, these are the solutions. The solutions and zeros are the same thing. That means x plus 3, x minus 2, and x minus 3 are the factors. So now if those are the factors, in order to find the polynomial in standard form, we're going to have to multiply this out. There are several ways to do it, but I'm going to show you a way that will make the problem a little bit faster. What I want you to notice in this problem is that two of the factors are opposites. If I rewrite the order here, and the reason I can do this is because the thing about multiplication is that the order in which you multiply does not matter. It's called the commutative property. When I multiply these together, this is called the product of a sum and difference. When you multiply them together, the middle terms will always cancel. So I'll show you. When you FOIL, you get x squared minus 3x plus 3x minus 9. And look, the middle terms are opposites. They're going to cancel, so I'm left with x squared minus 9. Now I only have left to multiply that by x minus 2. So when I go and multiply this, I get x to the third minus 2x squared minus 9x plus 18. And none of them are like terms, so I can't combine any of them. Now that's not the only way of doing it. If you wanted to leave it in the order it was up here, you could have. You could have multiplied these together first, and you would have gotten x squared plus x minus 6. And then when you went to multiply it by the x plus 3, I would have recommended you use the box method. So x squared, x, and -6 are going to be on one side. and on the other side is going to be x and negative 3. When you fill in the boxes, you're really finding areas. So this would be x cubed, negative 3x squared. This would be x squared and negative 3x, and negative 6x and positive 18. The solution is the sum of all those red terms because it's really just the area of a box, and to find the total area, you're going to add them all. Well, you can only add like terms, so these are like terms. So we have x cubed, and I have minus 2x squared, and I have minus 9x, and plus 18. And I would have gotten the same answer. Problem number 8. The Johnson twins were born 4 years after their older sister. This year, the product of the 3 siblings' ages is exactly 14 more than the sum of their ages. How old are the twins? All right, so let's start with this. There's an older sister, and then there are these twins that are the same age. So let's call the older sister X, because we don't know how old she is yet. That means that the twins are each 4 years younger than her, and they have the same algebraic expression. It says this year the product of their ages, so what I get when I multiply their ages together, is exactly 14 years more than the sum of their ages. So if I add the 3, that polynomial, we can find the age of the sister by graphing it. But in order to graph it, it needs to equal 0. And I claim to you that you don't actually have to multiply all this stuff out. You can leave it exactly like that. But you do have to simplify the right-hand side. So you would have 3x's, and 14 minus 4 minus 4 is 6. So in order to set this equation equal to 0, what I would do is I would subtract the 3x and I would subtract the 6. Now we can graph this on the calculator and see where it hits the x-axis. So I want you to notice that it hits the x-axis at both 1 and at 6. Here's the thing though. The sister is older. So if we say that the sister is 1 year old and the twins are 4 years less than that, then the twins are negative 3 years old, and that doesn't make any sense. So we disregard that solution. But if the sister is 6 and the twins are 4 years younger than that, then that would mean the twins are 2. And that does make sense, so therefore that must be the solution. Number 9 wants us to list the zeros of the function f of x is equal to 3x squared plus 7x minus 5, rounded to the nearest thousandth. Now, there are 2 ways of doing this. The one way of doing this is you could put your equation into y1 equals, and then put 0 into y2 equals, and find the points of intersection using the intersect function on the calculator. I'm not going to show the calculator here, so I'm going to do the problem the other way. You do not have to do it this way on the test. You can use the graphing calculator, that's fine. But remember that anytime you have a quadratic equation, if you don't know how to solve it, the quadratic formula works every time. Whether the answers are real, imaginary, irrational, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So in this case, a would be 3, b would be 7, and c would be negative 5. So x is equal to negative 7 plus or minus the square root of 7 squared minus 4 times 3 times negative 5 all over 2 times 3. When I go to simplify this, I always do this first. I always do what's underneath the radical next. And then I do the denominator. And now I'm going to use my graphing calculator to finish. I'm going to do -7 plus the square root of 109, and I'm going to divide that answer by 6. And I'm going to get approximately 0.573. That's rounded to the nearest thousandth. Thousandth is the third number to the right of the decimal. -7 minus the square root of 109 divided by 6 is approximately -2.907. But you should get the same answer if you graph it and use the intersect function. Problem number 10 says let f of x equal x minus a squared times x plus 2 times x plus b. How does the graph of this function react at the x-axis? Well, the first thing I want you to notice is what the zeros are. The zeros are at x equals a, -2, and -b. So if I make myself a just generic coordinate plane here, I don't know exactly where A is, but I know it's positive, so we'll just say it's over here somewhere. I know one of my solutions is at -2, and the other one's -b, and I don't know where that is. So because A has a multiplicity of 2, I know that the graph, whatever it looks like, that's probably not good. First of all, I've got to remember it's a 4th degree polynomial. There we go. That's what it'll look like. So what's going to happen is at -b and -2, the graph is going to pass through the x-axis because they had multiplicity 1. When a factor has multiplicity 2, the graph bounces off the x-axis. Notice that it has a little quadratic shape at the x-axis. I'm not sure what the multiple choice question answers are going to say. It may say something to that effect, where the graph has a quadratic shape at A, or that it bounces off the x-axis, or something to that effect. In problem number 11, it says the length of a box, here's my box, is 5 times the height. So we'll call the height x, and the length is going to be 5x. And then it says the sum of the length, the width, and the height is 18 centimeters. We want to find the dimensions of the box that will maximize its volume. Well, in order to do that, I need to be able to plug an expression for the volume of the box in the graphing calculator. But in order to plug it in the calculator, I need an expression for the length, the width, and the height. And I only have the height and the length, I don't have the width. But they did tell me that if I add these three together, I'm going to get 18, which means that I could solve for an expression that will represent the width. Solving for W tells me that it's going to be 18 minus 6x. So now the volume, which is length times width times height, is going to be 5x times 18 minus 6x times x. In order to find the dimensions that maximize the volume, I need to graph this and find the maximum and find the ordered pair. When I find it, x will be the height, and so I'll know what x is so I can find the length and the width. And I'll also know the value of the maximum. The nice thing about this Desmos program is on the graphing calculator, you have to play with the window in order to sometimes see where a maximum occurs. Desmos, I can just zoom in and out using my fingers on the iPad, or on the calculator, or on the computer, use the zoom in and zoom out function. So playing around with the Windows screen, I was able to find that the maximum when I graphed this function on the calculator occurred at 2, 120. That means that x is equal to 2, and that's my height. The length was 5x, so the length is 10. And the width was 18 minus 6 times x. So that was 18 minus 12, which is 6. So this was the dimensions. Were they in centimeters? Yes. These were the dimensions of my box. And the maximum volume would actually be 120 cubic centimeters.